This is a question that trips up almost all of our new Year 10 and 11 students, when it's really quite simple. Here, what a lot of students do is multiply both sides of the equation by the denominator, that bottom number, and get left with x squared plus 3x plus 2 is greater than or equal to 0. However, if we do it this way, we actually lose a lot of the valuable information. What we instead need to do is multiply both sides of the equation by x squared plus 4x plus 3 squared. That way we don't lose any information. What we'll be left with instead is x squared plus 3x plus 2 multiplied by x squared plus 4x plus 3, and all of that is greater than or equal to 0. Now that we have our new equation, our next step is to solve both of these quadratics as if it was a normal equation. So here we have x squared plus 3x plus 2 is equal to 0. Here we can do some simple factorization to get x plus 2 times by x plus 1. Then for our next equation, x squared plus 4x plus 3 is equal to 0, which can be factorized to x plus 3 and x plus 1. Now that we've successfully factorized both of our quadratics, we can go back to our first equation and sub those in. In other words, our inequality will then become x plus 2 times by x plus 3 times by x plus 1 squared is greater than or equal to 0. From here, we just graph our equation. So, starting with our intercepts, they will be at x is equal to minus 1, x is equal to minus 2, and x is equal to minus 3. Since the equation goes up to the power of 4, with x to the power of 1, x to the power of 1, and x to the power of 2, adding those together gives us x to the power of 4, we know that our equation should be starting in the positive quadrant to the top left and ending in the positive quadrant to the top right. In other words, we will approach our first intercept, x is equal to minus 3 from the top, then intercept x is equal to minus 2 from the bottom, and then, because x is equal to minus 1 is actually a double root, we'll bounce off this intercept and head towards the top quadrant, like so. And that will be our graphed equation. From here, it's as simple as looking at the domain and seeing which parts of the domain give us positive y values. So, in this case, you can see that that's x is smaller than or equal to negative 3, x is between negative 2 and negative 1, and x is greater than or equal to negative 1. However, we're not done there. Another common mistake students make is not going to the very beginning where we saw that x squared plus 4x plus 3 was actually in the denominator of our equation. In other words, the solutions for x plus 3 and x plus 1 are not valid values because, as you know, you cannot divide by 0. So, going back to our inequalities, we can see that our x is smaller than or equal to negative 3 should actually be x is smaller than negative 3, and anything that says x is equal to negative 1 should be removed. Our equations will end up being x is smaller than negative 3, x is greater than or equal to negative 2, smaller than negative 1, and x is greater than negative 1 for our final answer. If you found this helpful, feel free to drop a like.